Okay, so next we're going to talk about stress components. And we've already talked about how we might find the normal and tangential stress at a plane, at a point. And then the next thing is to think about what's going on in full 3 dimensions. So I'm going to underline that here. And in order to do that, so we started with our mechanics potato, looks something like this, right? And then we took off one slice, and that was how we looked at the traction vector, was to look at a point on this surface. And now what I'm going to do is I'm actually going to take some more slices, so we can talk about this whole thing in 3D. So first I'll take off that slice there, and now we're left with a quarter of a potato. And the last thing I'll do is take off one more slice here, and now we're left with 1/8 of a potato. And so what we're going to end up doing is we're going to end up looking right here at this corner, and we're going to think about what the stress is on each of these 3 faces. So now that we have our visual out of the way, I can wipe off my hand here, and we can draw this picture. So here's our potato, and I've drawn it in 3D. Now we only have 1/8 of a potato left, and we're going to look at this little cube here. And we're going to look at each face individually. You can see we're going to end up having 3 normals, right? We have this guy here, so that's N. We have an N for this plane as well, there. And finally, we're going to have an N over here as well. So we're going to end up with having 3 different normal vectors. And for the first time, we're going to talk a little bit about coordinate systems. So we're going to add in our coordinate system down here, X, Y, and Z. And I've purposefully aligned these with our normal vectors. So those would be the vectors that define our different slices. And so for this guy, that's going to be I hat, so that's going to be a unit vector in the X direction. This guy over here is going to be J hat, which is a unit vector in the Y direction. And this is going to be K hat, which is a unit vector in the Z direction. All right, and I'm going to try and draw these all in different colors so you can see them here. We're going to figure out what those traction vectors are. And I'm going to draw this guy down this way. This is going to be my traction vector on the Z face, so I'm going to call that traction Z. And so that means that the normal vector N points in the Z direction. That's why we have that Z there. In blue, I'm going to draw the traction vector from this side, which goes this way. And that's going to be the traction vector on the X face, because again, the normal vector is pointing in the X direction. And I'm going to have this guy on top here, traction vector that's on the Y face. Now, I should mention that these traction vectors are still equilibrating our external forces, which are over here somewhere. Okay, so what we're going to do is we'll actually look down here in Z. So I'm going to draw this face again right here. Do my best artistic representation here. So now here is our N direction, and we might be able to draw this. See if I can do this. No, that's going to be in the X direction. That's going to be in the Y direction. And so maybe our vector is going to stop right about there. So here, do it right there. So that again is the traction vector in Z. And you can see that we're going to have 3 different components. So first off, this guy there, that's going to be sigma z, so that's on the z face, just like the traction vector z. Oh, move that up here so you can see it. And it's in the z direction, so it's going to get a second subscript there. Next, we're going to have a vector going in the x direction, and it's tangential to the plane, right? So we are going to give those the name tau, and again, it's tau on the z face because it's the z. It's following the same convention as our traction vector, but now it's the tangential component that's in the x direction, and it's going to be I hat. This should be k hat. And this last vector goes down, and it's going to be tau z. We're still on the z face. It's in the y direction, and so it's going to have a k hat. So we put all those guys together, we're going to have tau zx I hat plus tau zy j hat plus sigma zz k hat. And this guy here is the normal component, and this together is our tangential component. And all we've done here is instead of having our traction vector components be normal and tangential to a particular plane, we've chosen those planes, in this case, to correspond to our coordinate axes. And just to think about subscripts here for a minute, subscripts. So the first subscript is the face, and so this is really thinking about what direction n is in. And the second subscript is the direction, and so this is going to be talking about whether it's normal or tangential to that plane. So this is going to be about whether the vector goes in the I direction, the j direction, or the k direction. Okay, so now we can do the same thing for tx. That's going to be sigma xx, so that's the normal component, I hat plus tau x, we're still on the x face, y j hat plus tau x z k hat. And we'll finish up on the y side, so that's tau y x I hat plus tau, sigma y j hat plus tau y z k hat. All right, and so what we can do with all of this information is we can start to think about a different representation. So we can start to look at a cube. And so we have our cube here. I'll do my best to draw this guy. And so now we have a different representation. At the top here, we can have our sigma yy, which is the normal stress on the y face. We also have the tangential component. We're going to call that tau yx. That one here is going to be tau yz. On the z face, so that's the face that's pointing in the z direction, we're going to have sigma zz, the normal component. We're going to have two tangential components, one that's going in this direction, that's tau zx. We have tau zy. And on this face over here, we have a sigma xx. We're going to have a tau xy. And finally, we're going to come over this way, and we're going to have a tau xz. And so where in 1D we had one stress we had to worry about, which was just our normal stress, now we have 9 components. For 3 faces. And of course, in reality, we really want a stress cube. Which would be some small volume. And that means there are 3 more faces, which equals 9 more components. So going from our potato all the way down to our cube